All right, good morning, guys. Today we're doing 10.5 central angles and arc measures. This is the beginning of the second part of Unit 10. And the main focus for the second part is that we're going to be talking a lot more about angles and different measures of things on a circle. So in the first part, we were talking about a lot with line segments and the circumference and the diameter and the radius, and all that's still true, but now we're just focusing on more of the angles. So the first big important vocabulary word is going to be the arc. An arc would be the part of the perimeter of the circle defined by two endpoints. Okay, so it is a part of the perimeter. So an example would be from B to C. What I like to think about is if it was pizza, you know, we've got our pizza and then we've got our maybe our pepperonis, whatever, right here. Cool. Well, the blue would be the crust, even though the crust is never blue. The blue would be the crust. And so the symbol you would write to show that you're talking about the arc is you'd put the letters BC from endpoint to endpoint. You'd put a little curve on top to show that it's an arc. Okay, and there's some different types of arcs. A minor arc is an arc with a measure that's less than 180 degrees. Okay, 180 degrees would be half the circle, so minor would be less than half the circle, less than 180 degrees. So an example of that again would be BC would be an example, or I could say AB would be an example, or I could say AD is an example, or we could say DC is an example. Okay, so all four of those are less than 180 degrees. They would be minor arcs. They can be different measures themselves, but they just have to be less than 180 to be a minor arc. So then major arc, you guessed it, is an arc that is greater than 180 degrees. So an example for that would be if I'm starting at B, I would have to go all the way around past D because there's the diameter, which would make it 180 degrees. And so then maybe I go from B all the way to A. And so we have to be very careful on how we name these. You cannot say BA because that could mean that I'm going on the shorter side. I'm going with the minor arc. So we need to put 3 letters for major arcs. So we're going to put B, C, and then A, because if I trace B to C to A, well, that shows that I'm talking about the big major arc section of the perimeter, not the smaller part. And then we got to make sure we put our little arc symbol above it. Okay, so for major arcs, we got to have 3 letters. For minor arcs, 2 is fine. Another example of major arcs, of a major arc, would be if I started at C and I went past B, past A to D. So I could say that it's C-A-D with an arc. Okay, so 3 letters. Semicircle is exactly half, so that's exactly 180 degrees with endpoints on the, and this is specific to the diameter. And so for this circle, the example we actually have 2 diameters. We have that one going across, we have this one going horizontal. And so an example of a semicircle, we could say AC with an arc, or BD with an arc. Okay, but it's the endpoints of the diameter that end up making the semicircle. Okay, a central angle is, take a wild guess, it is at the center. Hey, I wonder if it's called that on purpose. And it has 2 sides that are the radii of the circle. And so, if we look at our example, we have B is right smack in the center. And then we have that AB and BC would be congruent, and they would both be radii. Those are R's, kind of, sort of. We'll go with it. Okay, so an example would be a central angle. We could say angle ABC. Or you could say angle CBA. Both of those have B in the center of the 3 letters. That's not a coincidence, and that's because it's the center of the circle, which again, if we're thinking about angles, would actually mean that it's the vertex, if you remember all the way back to Geometry A, Unit 2. So, you can have central angles, and there's going to be some math that we're going to be able to do with that here in a minute, but the sum of all central angles of a circle is 360 degrees. 360 degrees, very important number to remember. The degree of an arc formed by the endpoints of the central angle is, this is easy, congruent to the degree of the central angle. How convenient. If we're looking at this picture, the central angle is labeled 84 degrees. That would be the central angle. Well, since it's the central angle, that means that the corresponding arc to it, the pizza crust, would also be 84 degrees. How convenient. They're the same. Okay? So if you can recognize and say, hey, look, that's a central angle, its corresponding pizza crust or arc measure will be congruent. They'll be the same thing. So if we're looking at this again, the example would be, hey, look, that's 84 degrees. Well, the arc measure is also going to be 84 degrees. Oh, I'm sorry, I miswrote that. The arc measure is going to be 84 degrees for the central angle, but I could also have the central angle be the other distance all the way around. And so we'd actually have to do 360 minus 84. So let me do that real fast. Minus 84. So let's see. That's a 2. That's a 15. 1, 6, 7. Hey! So 267 degrees. Okay. And so both of those add up to 360, which is the total angle measure all the way around. And those two numbers have to add up to 360, otherwise it wouldn't work. So, going to number 1, we're taking a couple different ideas. The first idea I would suggest is recognizing that we have 2 different diameters. And diameters, again, we talked about a second ago, split the circle perfectly in half, which means that each one is 180 degrees. So from J to L, that's 180 degrees. And the other direction, 180 degrees. But it's also true for the ones in blue. If I go from M to K, that's 180 degrees. If I go this direction, M to K, that's 180 degrees. So knowing that this central angle is 21, well, that would then mean that this arc measure, because I know it has the little roof above it, arc, would also be 21 degrees. If I trace the letters J, N, M, that'd be J to N to M. Well, I know that's part of the diameter I was talking about a minute ago. So if I remove the 21 here, well, that would mean this has to be 159 degrees, because that would add up to get 180 in total, the semicircle. If we look at KL would be right there. I would also suggest, as you find out things, it might be a good idea to go label them, because in this instant, how convenient, if we remember something all the way back to Unit 2, we would know that opposite angles are congruents. And in this case, there's actually a fancier name for that, and that would be vertical angles. And so that's a really important idea, and it saves me a little bit of time and effort. So that's 159. If that's 159, which then means that this arc measure is also 159 degrees. Okay? So again, I would recommend labeling things as you figure them out. The diameter, vertical angles, all those are really going to be important ideas. So for them, if we look at JKM, JK to M, and again, you have to trace in the order it says, J to K all the way to M. Well, that is kind of like the entire pizza, except 159 degrees. It's like the whole thing in getting rid of the 159, which would actually be 21 plus 159 is going to be the part that we want, JK to M. So let's see, we have 159 plus 21 and another 21. So 1 and 9 would be 11. 2 and 2 is 4, 9 and 10, and 1 is 201. So that means that has to be 201 degrees. Okay. And then again, if I trace MKL, and you got to go in the order that it says, and it's talking about the outside arc, M to K to L. So that is wanting everything except that middle section right there. So again, if I'm tracing in the order it says, M to K to L, if I were to travel from M and go past L going to K, well, then I'm going out of order from what it says. So I cannot start shading to the right-hand side. You have to go to the left first, go to the letter it's talking about, which was M to K, and then go to the L. So that's where we're getting everything but this middle section right there. So then you could do the entire total at 360 divided by, or I'm sorry, minus the 21 we don't want, which would then get us 339 degrees. Okay, so there's the first one, kind of chaotic, but I would highly suggest as we go to number 2 that you pause and try to do this one on your own. I would highly recommend it, but I'm just going to keep on going. So we have a central angle right here, which is 87 degrees. I see one single diameter. One single diameter. Oh, actually, that's not true. Here's the second diameter. That's convenient. So that would actually mean that this angle and that angle are congruent. So if this arc measure is 72, that arc measure is 72, and then we've got vertical angles, so that's 72. Then if I know this is a diameter, and all diameters are 180 degrees, that means if I say 180 minus 87, and then I'll subtract the 72, I can find this section. So that's going to be 93 minus 72 more. So that means that small section right there is 21 degrees. 21 degrees right there. Okay. Then, again, since all of these are central angles, if you wanted to, and it'd probably be a good idea, you could label all these outside arc measures as also all of these things, because they're all central angles. They're all going to be congruent. So I mean that is 72. So there's one section we have left to find, and that would be this one. So if we, again, look at our diameter idea, this is a diameter right here. So that means this entire part is 180. So if I get rid of the 72, that means this has to be 108 degrees, which means that's 108 degrees. So then I can go and fill out my table. So let's see. We've got the measure of angle UXV. So let's trace that. U to X to V. We figured that out. 72 degrees. Then I'm looking at arc ST. We figured that out. 21 degrees. Then it's VW. WV, same thing. But that's 108 degrees. And then we've got TW, so T to W. So that's going to be 72 and 21, which is 93 degrees. And then we've got TVW, which is actually going to be us going the other way. So we're at T to V to W. So that's everything but this section right here. So that would be 360 minus 93. That's 2 and a 1 and a 1, and that's 15. So that's 7 and 6 and 267. All right. So all that should work out. I know I'm going really quick, but you can either rewind or you can go check the notes key that's in Canvas. Okay. Going off to number 3, again, I would suggest pausing if you want to go try it on your own. It's really important that you can obviously do this on your own. So that's 90 degrees, which means that's 90 degrees because it's a central angle. If this is the diameter, that means that's 90 degrees as well. If that's a diameter, that means this is 90 degrees, 90 degrees. Lots of 90 degrees going around. That would also mean that this whole thing is 90, so if that's 34, that means this has to be 56 degrees, inside and out right there. And then we can just go label stuff. So CD, arc CD is 90 degrees. We have arc FD would be 90 plus 1, or plus 34 would be 124. Then we have DCF, D to C to F, which is everything but the section we just found. So that's 360 minus the 124. Borrow, that's a 51632, 236 degrees. And then finally we have from G, and I've got to go up past D to F, so everything but 56, which means this is 304 degrees. Okay. Number 4, you can just go look at the key if you want to look at the key. All right, off to the next page. So now we're going to be doing some stuff with equations. We need to find each of these measures over here that it's asking for, but I need to solve for x first. A to C would be a diameter. B to D would also be a diameter, which means these are vertical angles. And if those are vertical angles and they're congruent to each of their arcs, well, that means the two arcs are congruent. So I can say 8x plus 12 equals 10x minus 22. Move the 22 to the other side, so that's 34. Move the 8x over, so that's 2x, so x equals 17. Got to go plug it in to find the actual arc measure. So that's 10 times 17 minus 22. That's 170 minus 22. So that would be 148 degrees, which means that's 148 degrees. And again, if this is a diameter, and diameters cut the circle perfectly in half, if this is 148, that would mean this has to be 32 degrees to finish the semicircle. And so now we can say that's 17. And I'm going to have to pause for half a second.